Welcome everyone to the Support Vectors meetups. Today we have Ganges here, who will be talking on a very interesting topic, a GraphRAG. And he is going to give us a code walkthrough showing how to use it and the powerful use cases that it brings. So with that, I'll yield to Ganges now. Ganges, if you could please share your screen.
Yeah, thank you, Asif. Hi, everyone. Just to give me 1 minute, let me get my presentation on. Right, okay. So do you see my screen, everyone?
Yes, we can see your screen.
Okay. I don't know which one I'm showing, but is this a Google Docs?
It says PDF, the introduction to GraphRAG. It's a Google Doc.
Okay. All right. Maybe like I can use that one. That works. Let me do that up here. Okay. Slideshow. Okay. All right. Okay. Good evening, everyone. And if everyone is there for quorum, then I can get started. Thank you for joining this wonderful evening on Wednesday to listening to this introduction to GraphRAG. Okay. So this is sort of like a part one. I want to kind of take you through an introductory session on the GraphRAG. So basically like what that knowledge graph and how that can be utilized in conjunction with the naive RAG, so that like we can make it more helpful and useful, particularly like in the query summarization or question answers with the private or the enterprise data, as also like the large corpus of data in order to reduce the hallucination and make it more grounding towards the factual aspects. So with that, okay, let me start. Okay, so today this is going to be like a little bit like loosely based on the lot of vendors who have like this knowledge graph and they have integrated with the Llama index. So most of the code walkthrough is in conjunction with the Llama index, as well as like one or two vendor solution from the knowledge graph, or maybe like a graph DB. So there is one notable or two notable are basically Nebula graph, which is an open source solution, and I'll be like using that one to do the code walkthrough. But also like there are a few other examples which I'm going to showcase in terms of building this pipeline. So to start with, okay, what is GraphRAG? So basically, like just created this simple equation. Again, this is influenced by Professor Tom A, who has introduced this sort of like a presentation style where he's sort of like do everything AI by hands. So I'm trying kind of like mimic the similar thing, but as much as possible. But this is the first session I'm doing, so which may not be like as eloquent as what Tom A was doing, but I'll try to kind of like do a little bit like based on that. So GraphRAG equation, what it means is, okay, so we are taking the naive RAG, which is like the later part of it, which we all know about it, what RAG means. So basically like a querying plus prompting and context with interfacing with the LLM. So in order to sort of like grounding the text local to the query by doing this vector search, basically like doing the vector embedding and then like going through that vector search in order to get the top K, and then using that as the context, providing that to the LLM and get the answer. So it's all like we know about it. But still, there is a potential. It's not always perfect. Rather, like because of the large context window, you may not have basically like you will be like chunking that document into smaller chunks. When you do that, like the top K, there could be a potential, or maybe like you may lose some of the information which is not part of that top K. So, for example, like if the corpus is too large, and if suppose there's some of the information which are like factual and which are connected may not be available during this, like the smaller corpus, what you have gathered for like your top K or top nearest neighbor. So, which means that, okay, it may not have the full context in terms of like a summarizing or answering that question. And if you have a large context, and then there is another potential loss in the middle. So that when the large language models will try to summarize, at the time also there is a possibility of losing the information. So how we can tackle that in the scenario, and how we can make it more better as well as like more factual. So one way is this is where like the knowledge graph comes into picture, where we can couple this thing with the knowledge graph. So basically like getting all the facts, building that the factual data with the interconnections of all the entities and the relationship within that the context. So that way you can sort of like query that one, traversing that graph and collecting all the pieces, whether it is near or far end of this corpus. So that way, like you can have better contextual information on top of that top K. So if you can combine those two things, then you will have a better results, and you can reduce further reduction in the hallucination. But I'm not saying that, okay, completely like eliminating the hallucination, but it will help to make it more grounded with the factual data, rather than like the LLMs will try to sort of hallucinate on some of the information which is not available through that in the top K chunks. So at a high level, okay, so we are going to have the knowledge graph, and then we are going to combine that with our naive RAG. So that's what all about is. So today's topic, we are going to cover mostly on the knowledge graph side. So because already we know what RAG is, right? So before we get into that, the knowledge graph, and again, this talk is not about the what is knowledge graph, because this is, I'm going to assume certain things, or maybe like I'm giving a brief introduction about like what the knowledge graph and the taxonomy is, so that we can build a baseline, and then like we can jump into this code walkthrough in terms of how we can utilize, or how we can build this knowledge graph from the sources itself. So for that, we need to have some sort of like an example, and then the background. So there are a couple of things. So one is this: when you build the knowledge graph, the knowledge graphs are built based on these triplets. So the triplets are on the right hand side of the screen. You see that, okay, subject, predicate, and object. So basically, like what it defines is you have a subject which is an entity, and then like you can have the relationship, how these entities are connected to each other. So it can be like a connected one to many, or many to many in that relationship, and then like you can traverse within that graph using the query language called Cipher. The Cipher is on the left hand side of the screen, where it is defined by Neo4j. So this is it's sort of like a SQL kind of a thing, but again, it has its own ISO standard. So basically, like, become a more standardized version, so that it is agnostic to the vendor in order to utilize this querying this knowledge graph using this Cipher language. So the advantage of like doing this one is why, maybe like we can ask that, okay, hey, why can't we use the SQL itself in order to do this? Yeah, you can do that, but SQL is very expensive in terms of the computation. Particularly like you need to kind of write a lot of joins and multi-joins, etc., etc. And also like it will be little difficult to traverse into the SQL because sometimes like a SQL go long pages of SQL statements. That depends on the depth of the graph and the breadth of the graph in terms of the relationship and other thing. So the graph query language is more easier in order to traverse the graph. So that is the reason why like it is more advantageous. So then to define this one, like each of these vendors, they have a little bit of like a difference in the implementation, but largely like it covers this like the triplets. That is the baseline. But again, like there is like tags, entities, edges, and relationships. So basically, like let me just give you very high level what the tags means. So the tags are a group of entities. For example, if you think of an aircraft, right? So aircraft, if you want to put them into a tag, so all the aircrafts could be in the tag with the name called aircraft. But then you can have a different models of the aircraft, maybe like a single engine, multi-engine, and the propeller based, etc., etc. So which means that okay, it have some sort of like a differentiation, but it belongs to the same family of aircraft. So that is the level of like a tags. Then the entities are individual the aircraft. So aircraft with their name and their make, model, etc., etc. And then you can have a lot of other data you can bring in terms of like, for example, like the aircraft with the tail number from which routes it is covering and what time it has covered and if it has gone to the maintenance and what time it has gone to the maintenance, etc., etc. So you can sort of like drill it down to the level of each and every part of the aircraft. You can build this entire knowledge graph, if you will, in terms of the for that particular asset. And then you can have this relationship between like the parts and whatnot, which is been like a makeup of that aircraft. So it has like the relationship. So that is the whole sort of like if you will, if you want to build that asset model for the knowledge graph, you can do that. The reason why I'm giving that example is because I was working at GE Digital in 2016. So basically, like I was sort of like managing this product, and we developed this knowledge graph and a design tool for that one. So I give a little bit more story when we kind of go along with that one, but just introductory things for the taxonomy. Let me.
Can I ask a question?
Yes, please.
So what itself is a knowledge graph? I didn't get that because your data could be in a database or could be in files. So from that, how do you create the knowledge graph that you can use? So that part is not clear to me. Could you explain?
Sure. Yeah, that is what we are going to talk about in the next slide. Okay, so
go ahead.
Wait for like 1 or 2 slides. So basically, like we'll get into that. Okay, that is the core part of this discussion today. Okay.
Okay, perfect then. Thank you. Sorry for jumping the gun.
No worries. Okay, so this is a little bit like again another example, which is more given a perspective of like what we discussed in terms of the taxonomy. So if you were kind of like do a Google search, meaning like for Albert Einstein, so you see the result. Okay, so they developed. I mean, they are using knowledge graph, basically like making the connections and etc., etc. So that's where like they are bringing that the related information about the person or an object or a subject you are querying for. So which means that, okay, they built that knowledge graph in the back end and they were serving through the search. So for example, like in order to give some perspective on this, the triplets, what we talked about in the previous slide. So when you look at this, the graph and the triplets there. So Albert Einstein, born in German Empire. So basically, like you see the subject and the relationship and the object. So how it is like related. So this is what like we are going to build in order to use that. That is our the graph or the source when we sort of like do a search or the query along with the naive graph, naive RAG. Okay, so just to give an example of like what that subject, predicate, and object or with the triplet. That's an example here. So this is again, which is I was talking about this asset, which is like in the aircraft and all that parts which are connected and everything. So this is one of the product which I was managing back in G Digital. So basically, like we developed. So funny thing was it was happened on like a 2016, 2017 timeframe. At the time, a transformer was not there. So basically, like the NLP was not at the limelight, at least like for this sort of like work. So I was like dreaming of doing something what is possible today. For example, I want to create, I mean, we have created the knowledge graph through some other way, not using the LLM and et cetera, but we have the knowledge graph developed, the schema was developed, and people have like used the CSV file to kind of create this knowledge graph. But my ambition or that my wish at that time was I want to query this knowledge graph using the natural language. Okay. So for example, like saying that, okay, get me all the aircraft of this model, which is being maintained between this time to this time. Okay. So somewhere like this natural language has to be converted into a query language, and then it can go ahead and like query that internal database so that, and then it can either, I want to get the summary of that result. Okay, that was the wish list. That was a tall order for me to kind of ask this one to my engineers. So basically, like they struggled, but we, at the end of the day, we got like some sort of like a rule engine. So this is like just a backstory. So today, if I want to kind of do this one, okay, now it is possible with large language models supported with the RAG. It is very much possible. Now, okay. So Albert, this is what your question is. So saying that, okay, hey, okay, I get that, okay, what the knowledge graph is and that the structure and everything. How do I build this one? Okay, and where to get started? So there is like a two ways you can do it. One is, or maybe like a three ways. One is already there are enterprise companies or the enterprises, they have defined their schema as well as like they have defined this graph structure. So which means that, okay, that could be a starting point from there, like they can utilize that existing knowledge graph. But if you want to do it like from the ground up or maybe like starting new, you may say that, okay, I have a bunch of documents. Those documents are unstructured. Basically, like it could be like a text document or the PDF documents, et cetera, et cetera. So how do I go about that? Okay, so this is the pipeline. So the pipeline is you take the docs and you can push it into that LLM, using the LLM to create a schema. So basically, like you can define some sort of like a triplet schema and then ask the LLM to generate the graph. So that's where the schema and the prompts are going to be provided to the LLM as an instruction to generate the graph. So which means that, okay, it is completely like automated so that by running this pipeline, you input the doc and that output is going to be the graph, right? So this is the 100,000 foot level pipeline. Now, how do I use it? Meaning like, what are the ways I can do it? So there is like you can go completely like with the from the scratch, say that, okay, here I have a fine-tuned model with the data set of like how the data should look like, but to with my knowledge graph schema, and then I'm going to train the model to fine-tune the model to generate this graph, okay, based on the text data. That is one way to do it. And then the second way is there are like already some abstraction has been created by Nebula Graph or maybe like a similar vendors, so that they have created this prompt. So all you need to kind of give the docs, it will generate the graph for you. Okay, so that is the second way. The third way is there are like tools which are available. So basically, like you can provide that CSV file and it can generate the graph. So this is like the levels of like the complexity as well as like where you want to go and how big that the graph you want to create. So certainly like the one thing which is it removes the burden is you don't need to be an expert in the knowledge graph, right? So basically like you then the heavy lifting of taking the unstructured data, which is the text data or the documents, and converting that into the graph using the LLM, that is possible very much today. So Albert, is that answering your question, or do you have any more question on this?
Very clear. Thank you.
Okay, so I'm going to do a switch right now in order to kind of show you you guys the code. Okay, for the first one, so which is the Rebel Llama Index Knowledge Graph Query Engine. Okay, so did you guys see my screen? That still you're seeing that the same screen, or
Yeah,
We're still the PowerPoint. Yeah, we're still seeing the PowerPoint.
okay? 1 second. How do I switch the screens? Sorry, 1 minute.
It has a way to, in Zoom, to select the screen you want to project.
Yeah.
Share, yeah.
Ganges, just click on the share screen icon.
Correct.
And pick the next screen.
Okay. I'm not seeing the. Okay.
Okay, what I'll do is
Top right-hand corner.
I'll stop the sharing so you can start the sharing again.
Okay.
Now you share again.
Not seeing that the window itself.
You should be seeing the controls on your screen somewhere. You'll see a bar.
Host needs to allow a co-host.
Ganges is a co-host.
Yeah, I'm the co-host, but I'm not seeing the control.
See,
Okay, okay. It is somehow it is like minimized. I don't know how to get that.
Zoom does that. Just click on that box, minimize box. At some place you'll see a diagonal arrow to maximize it again. Do you see the control to expand it again?
No.
Okay, let me show you.
Oh, okay, okay, okay. So hold on 1 second. I see it. I see it. I got it. Okay. It is on the second screen. Oh my gosh. Share. Okay. Do you see a collab screen?
No, we still see the first screen. How about just dragging that collab onto this window?
Yeah, that is what I'm trying to do now. Sorry.
Yeah, this is all right. Take your time.
Can you see now?
Yeah. Yep. We can see the collab
Collab?
now. Yeah.
All right. Okay, cool. All right. So continuing on this knowledge, the LLM based generating graph. So
We're seeing
So
your Jupyter notebook. Is that the right one?
Jupyter, yeah. So this is a collab, right? Collab
Okay,
notebook.
perfect.
That's what
Yeah,
you were
yeah,
saying,
yeah. Okay, got it. Perfect.
right? Yeah. Okay. Yeah. So I probably may not run all the cells because I ran it in order to kind of keep the time in mind. So basically, like yeah, this is a model which has been developed by a company called Babelscape. So Babelscape is developed a data sets based on like um, a few large corpus of data, which is like New York Times plus a few other sources, and you can find all these things in the Hugging Face. So do you see my screen, Hugging Face, right?
Yes.
Yes. Yes.
All right. Okay. So this is based on this one, right? So basically, like anybody can kind of like take it and then like run it so that like any document you give, you can generate the triplets, and then you can define the schema based on the schema. You can develop that one. So that is what I'm going to kind of like walk through here. So basically, like first they are doing like with the it's a pretty standard thing. So we all know about like how to kind of use the transformers and the pipeline. So basically, like here it is saying that okay, hey, this is going to be a text-to-text generation, and then the model is Rebel large. So then the tokenizer they use using that. Okay, they are sort of like creating this like a triplet extractor. And then this is the function which has been created by them. So basically like to extract the triplets, which is like the same as what we discussed about like a subject, predicate, and the object. So that is what these definitions are. So using this definition, we're going to kind of build this graph, build a graph. So I'm using OpenAI. You can use even if you're going to use like some local models, which is like Llama 3 or Mistral, you can use up to your choice. But basically, like can do that. And then I'm going to give. I'm using this text file to create the triplets. So the text file is basically like this is one of the essay by Paul Graham. So which is he wrote that essay how to start Google. So basically, like it's talked about like the startups and the startup what that do you kind of like need the mindset and the background in order to kind of do the startups. So okay, we're not going to do that much. So basically, like using the document and
Can I ask a quick question? So
Sure.
there are two models here. One is your Paul Graham document being fed to Babelscape Rebel Large, that's producing the schema, helping you build the schema, tokens in the schema. And then after that, you are feeding that into OpenAI to prompt it and then create the knowledge graph.
Okay, so that's correct. You are right. So to create that index, okay, so basically like they're using, I mean, we are using like a OpenAI model. So basically like it is a text-to-text generation. So to create the triplets are being created using the Rebel models. And once the model is, once that the triplets are created, so using this function, they are going to create the triplet. So basically, like you can see that, okay, the knowledge graph index is being created using the triplet. All right. And then like you can use this OpenAI LLM to do the querying at a later stage. Okay. So this is like just to create this the graph. For that, they're using the Rebel. using the
Correct.
Rebel, you can do it. And then for the querying, so the querying is going to be based on the OpenAI.
Mm-hmm.
So, sorry, Angus, in one of your earlier slide, you are showing LLM to create the graph model. So, but what you're saying now, we are using the Hugging Space model, right? What's called, I forgot the name, to create the graph. So it's not, we are not using LLM to create the graph model. Rather, we are using the model that you mentioned. What's the name? I forgot that.
Rebel. So Rebel that itself is a language model. Okay. So for example, if you go here, okay, so let me walk you through here.
I mean, that made it clear. So that itself is a language model.
Yes, yeah.
Yes. Okay. Thank you.
So it's a bot for conditional generation. So this is the model they are using to create that the schema. So basically like the triplets. Once you create the triplets, that is what you are creating the graph. Now you have the graph. Okay, you are going to you are indexing that graph using the Llama index. So basically like getting into the store and then like you can start querying on that one. So that is the later part.
Understood. Thank you.
Right. So once that is done, this is the querying part. So in the querying part, you can ask the query based on the index. So because like the index is like created and it is not stored, but basically like you can keep it as storage. I will walk you through that in the next example with the Nebula graph. So basically like you can create a storage and then you can put it in the storage and then you can query that from the storage. So this one is like in memory. So basically like you are just asking that, okay, index as query engine. So basically this is again the Llama index, the tooling. So then you can use that engine to query that one. So what is that author? So what I did was, in order to kind of create this, the question, I went to ChatGPT. Then I sort of like gave that the entire corpus to ChatGPT. Say that, okay, hey, give me like 5 questions to query from this one. So it generated like a 5 questions and start kind of like using that question to query it. Okay. So here, there's one thing. In this one, it is not querying the large the corpus itself, right? It is not combined the knowledge graph plus the naive RAG. So it is just kind of going through only that knowledge graph and fetching the data, and then it is summarizing that. Okay, so that is what it is doing here. So I said like 5 or 6 questions. So basically, I got that one. Then basically, like you can see the visualization. Okay, so this is not very helpful. I'll give you like in the next example, I can show you the better visualization on that. So this is completely like you are taking that LLM model and then like using that LLM model to create the graph. So you are defining this your function to how you want to kind of like strip the data and then like how you want to create the triplets, right? So this is one method. And then the second one is, I guess, see my another Python notebook, or you're still seeing the same collab?
No, it's a different notebook. Yes, KG Index, OpenAI.
Right. Correct. Okay. So, sorry, I'm just switching because I've been like using 2 or 3 windows to do it. So this is the second one, which is using the Nebula graph. So so let me jump to one more thing now. I want to give you going back to this.
So this is the second option, correct?
Correct. This is the second option.
Okay.
Okay. So you see my slide deck, right?
Yes.
Okay. So just I want to quickly like go to the slide before I show this the notebook. Okay, so in this case, like what we are going to do here is, okay, this is sort of like a roadmap in terms of like using the Nebula graph and not using the language model to create the schema, but it is abstracted, okay? But it is doing the thing, but it is abstracted in a way because the Nebula graph is using some methods, kind of like a prompts to sort of like create that graph. So which is completely abstracted from the user or from the developer. So on the right side, it will be a little bit clear here. So what we discussed in the earlier slide or in this earlier demo was the top portion, because we took the fine-tuned LLM or the NLP models to do the knowledge extraction. We are sort of like a fed the raw data to the fine-tuned LLM, which is the Rebel, and then we extracted the knowledge, the schema for the knowledge graph. In this one, this is LLM orchestrated. So what we are going to do is like we are using the prompt, and it's basically like the Nebula graph. They provided certain APIs, and we just kind of like call that APIs to extract that information from the docs. So basically, like we just provide the doc, and then it will build that knowledge graph for you. And using that knowledge graph, it will be like pushed into the store, and then like once that the knowledge graph is pushed into the store, then you can do the graph coding. Okay, so that is the roadmap we are going to follow now. So going back to the screen, okay. So here, usual imports. The important thing here is, okay, I'm going to use the OpenAI. Again, the OpenAI is for the coding time, not for the building time. Okay, so now we are going to kind of build that knowledge graph. So here, so the Nebula graph, you need to have a Nebula graph running on your system. So basically like there is a Docker version, or you can just download it, the Nebula graph for the developer thing. So basically like it is a distributed system. Basically, they're using a clustering mechanism to sort of like deploy that Nebula graph engine. Once you start running that one, it will be like exposed in this location. And then like all you're sort of like saying is, okay, hey, this is my space name. You have to create a space. And then once you create the space, then you have to use the space to create the relationship entity, et cetera, et cetera. So this is like a more of like configuration driven rather than like the code driven when you compare with the previous case. Now, once we do that, then we are going to prepare for the graph store. So again, this is like similar to any other storage definitions, what you do in the Llama index. This is like for the graph store. They have integrated, the Nebula graph has integrated with the Llama index to create that graph store. So once you define that graph store, then you are going to use you are going to feed the document to create. That's the step one. So we are going to load some document, and then like we are going to use the document to create the index. So basically like when I say index, it's basically like extracting the information or the schema for the knowledge graph. Are you with me?
Yes.
Okay. So now you take that one, and you basically like I'm using that. So here, if you look at it, the OpenAI is being used to extract the graph, but there is a prompt which is being like utilized internally. Okay, so this is like completely like a master from the user. So basically like all you are defining is, hey, this is my space. Basically like I want to create a maximum triplets per chunk of like a 10. So what happening here is like it is going through like the chunking of the document, and basically like doing the embedding, and then using the chunk to extract the triplets and creating the triplets. That's what it is doing. Once you do that, so this particular compute is a very expensive compute, because you don't want to kind of like do it like multiple times or maybe like over and over again. Once you extracted the data, you can sort of like persist the data. So that is what it is providing here. Once you persist the data into the disk, then you can use that persisted data, load it from that persisted data to do that the query, okay, at a later point in time. So here I have persisted in OpenAI storage graph. So basically, like that is what you can see here. It is like created that the extraction and put it that into that indexed in the JSON format, and then I'm going to load that from that storage. Once I load that into storage, then I can use that for summary. So here, okay, you can, there are many different methods out there to kind of like a query that one as query engine. So basically like you can query that the graph. So for example, like if I query this one, I can tell me about Azim Chowdhury. So Azim Chowdhury is one of the character in the Guardian of Galaxy and how he is related to that context. So that is what basically like you can see here. So here I'm saying that, okay, hey, give me like a depth of like 10 with respect to Azim Chowdhury. And basically like it is sort of like well, all the connections what Azim Chowdhury has with that corpus of data. So it is basically like getting into the factuals. So you want to kind of like use this information, and then you can combine that with the query to extract the data. To extract or summarize or answer the question from the user query. Okay. So here, okay, so we are wondering that, okay, this is like, this is what like the cipher is being generated based on the user natural query. So when I say that, okay, hey, give me like, tell me about Azim Chowdhury. So basically like it is converting that into this ciphertext and then issuing that query to the knowledge graph and getting the data. So that's what happening internally when you do the query using the query engine. So for the visualization part, okay, so this is like a set. Yesterday I was like spending a lot of time in order to get this graph. Because in the VS Code there was a issue, or maybe like it is not working at all. Then I figured out like some code flow, some Stack Overflow, but still it is like a lot of wobbling here. So see, look at that. Okay, the corpus of data we provided, and it has extracted the data, and it is what like you can see here. Okay, so it creates the nodes. So basically, like each node is that entity. Could be a character or could be a location or a place or etc. etc. And then the edges were like connecting to other node, how it is being related to that particular entity. Okay, so once you start asking the question, it is traversing to that entity depending on the depth what you define in the query. It goes and collect all these related information, and that related information is what like it is creating a subgraph. So once you have the subgraph, then it becomes a context, which is like additional context for your naive RAG. So now what happens is you have this subgraph information, and then you have this naive RAG chunks, whatever you have collected from your top K similarity search, from the vector search, then you can combine those two things in order to provide a better contextual information to the LLM to generate the answer. So basically, like it becomes more grounded in order to get a better factual results rather than, or maybe like reducing the hallucination. That's how it is going to happen.
Yeah, I guess that once you get the subgraph, do you need to transform into any text, or the LLM understand the subgraph along with the other context? So underneath, what's
Okay, that's a good question. So the subgraph information will be okay. I need to check that one. Sorry. Maybe I'll get back to you on that one.
Sure. No problem.
Okay.
I mean, the way I'm thinking is, if the LLM, so the OpenAI, right? If they don't provide any native support to this, from somewhere in your side, client side, it's happening, right? Transformation.
Yeah.
All right.
Okay, maybe quickly we can check. So because the query engine is like abstracting that information, so it gives that the context basically. Maybe like I'll get back to you on that one.
Well, thank you.
So
Uh,
Ganges,
Hi. In the previous cell, we can see the JSON or the data. If you scroll a bit more to that, yeah. So whatever is highlighted in blue. Can you please explain what exactly that means? Is this each
Okay.
of the entity in the graph?
Yeah. So this is like I asked the question to the query engine. Okay, so this is going into the knowledge graph, whatever you have created earlier. Okay, the graph is there. Now I'm asking, saying that, okay, tell me about Azim Chaudhary in this case. Okay, and I'm saying that, okay, go to that depth of like 10 or 15. So basically, like it is going through that, all this context, okay, and then it finds the relationship of Azim Chaudhary with the connections. That's what it is. So it is giving you the triplet.
So is this the data that we are passing to the LLM as part of RAG, whatever is highlighted in blue?
Correct.
Got it.
Yes, that so in this case I'm not passing anything. This is like just a I'm printing here, but still I have not performed any summary query or question answer query. So this is just to kind of querying the knowledge graph alone. I'm
But
not.
this is not going into the database. This is purely in the document, based on the document and the schema that it has generated.
That's correct. So the schema is a graph, right? So it is just
correct.
kind of traversing the graph and getting the data. And it is not asking the LLM as a downstream task saying that, okay, hey, give me an answer to a question or summarize the thing. So it is not the downstream task is not done yet. This is just retrieving the data from the knowledge graph using the knowledge graph query.
And this is just to illustrate the data to us, right? I mean, you are just printing this as an information to us. Okay, got it.
That's correct. It is just so basically like the extracted keyword here is like Azim Chaudhary. So using this keyword, it is sort of like a traversing. Okay, so there are many different ways to kind of like go through this traversal. So here in this case, like it is extracted or maybe like a traversing through the keywords. I believe that, okay, Nebula graph, they said that, okay, they have not implemented all the other methods. They are sort of like still in the work in progress. So basically like one is the keyword and then the second would be like something else. So once they sort of like support those things, you can use the retriever mode as one of your parameter to this query engine. Then using that, you can retrieve the data from the knowledge graph. But again, this is just retrieving the data from the graph. Now, after that, next step, what you can do is you can feed this data plus the chunk data from the vector to pass it to the LLM to generate the answer for your queries. So that is like a downstream task.
When the downstream task, just like in the hybrid search in which we use something like Elasticsearch and vector database, are you suggesting to replace the Elasticsearch part with a knowledge graph?
Correct.
And do the keyword search? Okay.
That's correct. Yeah, you can think it that way. Yes, absolutely.
Ganges?
Yeah.
So as I understand it, there are two parts to building the knowledge graph, right? One is to create those triplets or those objects and then create the graph and have the connections between the triplets and the graph, correct? So the relationship is clear. And if you say level depth 10, it will go and find all the triplets and connect it back in the graph, correct? And then find the right answer. Is that the correct understanding here?
Okay, when you say answer, okay, so this is answering to the traversal question. Okay, you are just traversing the graph at this point in time. Okay,
Yes,
it
you
is not, you
traverse
are
the
not.
graph and then find an automatic connection with those objects and return back those objects, right?
That's
Those,
correct.
okay, clear.
That's correct.
It's just like a tree traversal in a way. If you think of it, goes down the tree and it has the nodes. So the first, those triplets are basically the nodes, and it connects back to the graph.
No, triplets are not just the nodes. Triplets are all three things. Basically, like the entities, which is the subject, object, and the relationship. It covers
got
three
it.
things. Okay. So which is like a nodes or the vertices or the entities you can call, and then like the relationship, how they are related to each other. So, or maybe like in this question, I'm asking, saying that, okay, hey, tell me about Peter Quill, or tell me about Azim Chowdhury, or tell me about John Gunn. So what it does is it takes this keyword, basically John and Gunn or Azim and Chowdhury, it traverses through the graph depending on your depth definition. It goes into the graph and traverse and get all the connected nodes and the vertices, I mean like the relationships, and it sort of like provide you saying that, okay, hey, this is how this person is connected and these are the relationship, right? So now you have that information because the when you look at like from the high level, right? So in the vector database, what you are doing is you, after the embedding, you are using some sort of like a vector queries to get like a top k. So what happens is like it goes and pick all this embedding information or the chunks related to that top k results, and it is giving to you, right?
Yes.
So it's a similar way it is doing on the graph. Now the power or the difference here is the top k, the chunks, whatever you have retrieved. Let's say, for example, your corpus is like a large corpus, okay? Possibly like there could be a meaningful or an important information would have been left somewhere like a tail end of the document. So possibly like it may not have the direct connections, or maybe like some sort of like indirect connection, but it is like still uh, uh, yeah, a meaningful one. So there is a possibility you lose that information by just doing the vector search alone. Okay, so this is where it is augmenting on top of it. Because it is easy to kind of traverse this relationship, you can pick up those the tail nodes or maybe like the leaf nodes very down into the document. So because it is easy to traverse. So once you have that information, now it is going to give you a little bit more additional information on the context to the LLM, right? So basically, like on top of this context, and it can fetch this. See, it is not just only like giving that the node. The node will have this the chunk associated to that as well. So
Got it.
ultimately, like, the LLM will have access to that particular context as well, so that it can use that context to generate the summary or answer.
Quick question. Actually, couple of questions here. One is when you have a query, there are certain keywords that are extracted, right? That's what you mentioned. And based on that, graph traversal or inference is done to get like the set of like whatever you showed in blue. So can we customize that extraction and give that as input? Like basically, I'm in my application, I might have my own way of figuring out what is important. So like the keywords, I can have custom logic to extract them, right?
Yes, yes. So this is like it's a prompt. Now it becomes kind of like a prompt, right, or the question, because in the query you can specify what you need.
Right. I can specify a query, but maybe I have very specialized application where I have a way to parse and get like, what is more relevant for me from the query, right? So instead of giving it like a sentence, can I actually like extract those keywords myself?
Extract the keywords by yourself. Can you give me an example? So let's say, for example,
so I work in a problem where we are looking at like, let's say some kind of user activity data. And
Okay.
I know that certain activities are more important than others, right? So like maybe I have, based on my application logic, I have a very custom logic to figure out, okay, if this is the query, then like, I need to parse these parts of the query. And like those are important for me. Like if I give it to and there are some things that are, there are some entities maybe in the real world entities that are not relevant to me. For example, yeah, so basically like, yeah, so that's the example.
Okay.
Let's say I have a database of how important each entity is for me somewhere else.
Okay. Okay. So,
right. So I only want to like, pick certain entities in the query and not like other entities. That's a good way of putting it. Yeah.
okay. Yeah. So the two ways to do it, right? So one is like, again, you can directly like write the cipher query. Okay. So in the cipher query, you can specify saying that, okay, with the word class, etc., etc. So there is a language, you can do that. But
okay.
Other way is you can specify your information, what you need and what you don't want, in a form of like a question itself.
Okay, somehow embed
Right?
it in the query. Okay.
Yeah, exactly. In the query itself. So that's the power of the natural language, right? Now, because like the way why we want to kind of like do that, I don't want to write it the cipher query. Rather, I want to express my my need in a form of a natural language itself. Okay.
Got
So
it.
if you
So
can
in this
able to do
case,
that.
maybe tell me about Asim Chaudhary could itself have been something that I extracted from the actual user query.
Exactly. Yeah. It's pretty specific at what it looks like, because he's not saying, tell me about all the characters in the galaxy. He's only asking for a specific Asim Chaudhary, actually.
Yeah.
Got it.
And
Got it. That makes sense.
you can say that, okay, tell me about the connections between Asim Chaudhary and the two other characters.
Got it. Got it.
Right. Or maybe like you can say that, okay, hey, give me like a relationship with Asim Chaudhary with only in this context. Meaning like when he was like traveling the rocket, or maybe like during in this location. So you can sort of like do that by prompting it.
Got it. Got it. Another quick question is, so in this example, you showed how to construct the knowledge graph. Suppose I have a Neo4j graph. So can I just build this Llama index thingy, knowledge graph, Llama index thingy with it directly?
I think so. Yes, you can do it.
I see. Okay.
Because Neo4j they support it, and I actually like I didn't have time to kind of like go with the Neo4j, because I just started with like a Nebula and then like one other thing. But certainly it is possible. You can do that.
All right. Thank you so much.
No worries.
Hi, I have one more question regarding the knowledge graph context. So we have Asim Chaudhary as our keyword, but then when we look at the context, it's almost at the bottom. So what is the order of these things, this data being returned? Like, why is Polter at the top?
It's a good observation. I need to check. Maybe like this is just a print, or there is any specific order is maintained here. So probably like I don't have an answer for that. Maybe I'll get back to you on that.
I don't think you have control on that. I think what it does internally is what is shown on the screen, as Krishna had pointed earlier. It figures out your best option with Asim Chaudhary.
Maybe there are some parameters that could be used to say how it traverses.
Exactly, right? So basically like the response mode tree summarize, there are like many different modes are there. So you can use that mode to kind of like change it. Because I have not gone through each and every parameter. Certainly like that is certainly like worthy for experimenting it. Okay. So I think quick time check, it is already 8:01. Let me quickly like see. I want to kind of like do a quick demo, but wait, let me run it through this few other slides so that like we can cover that, and then I can show quickly like a few demos if needed. So this is the large ecosystem so far I've kind of like gone through. So Neo4j obviously like they are the leader because they have been in this knowledge graph business for a very long time. And there is like Nebula Graph we talked about, basically like they are a very small startup, and then like they are doing a lot of work on that. And Cruise is another one which is like startup. Babelscape, we talked about that one, which is like they work, they built it like a fine-tuned model in order to extract the data, but they just kind of like kept it only at that level. Microsoft is like investing a lot into this GraphRAG. So this is certainly like going to be the next paper reading because they have come up with a, I mean, they released a paper, the research paper, which talks about like the GraphRAG from their perspective. And there's a beautiful videos and other things out there. And they are yet to kind of like release the code. So that is worthy to, I mean, to take a look at it. This is there are a few other easier way to scrape the web and then like feed that scraped data to generate the graph. Okay, so basically like the diffbot is one of them, and the other company which is let me show you that.
Scared graph or something?
Yeah. Scrape Graph AI. Okay, so Scrape Graph AI is this is like the easiest way of like generating the graph. So basically, like they are supporting like many different graph versions. So to see it. So you can go through this one, so because I don't want to kind of like read this one. So it's pretty easiest way of like giving your document or maybe like the URL so that like it can sort of like take it and parse it and scrape it, then it builds the graph. So this is one thing, and certainly like the other one is the diffbot. So diffbot is also doing the similar thing. So these are the two things. So then the Microsoft is a pretty interesting one. So when you look at it, like, okay, so there's a pretty good article they have written. It is like good to kind of like read it. So they sort of like did that the baseline rag, which is the naive rag, and then the graph rag. They sort of like compare and then see how well that graph rag is performing when compared to the naive graph. So they use the two data set, which is like a pretty large data set of like a 2 billion or 10 billion, 2 to 3 billion data sets. And then they sort of like use that to kind of build these algorithms. So this is one of the results saying that, okay, how well the graph rag is performing when compared to the baseline rag. So this is we'll read this paper next time a little bit deeper. For the time being, we can quickly move on to this. What else I have? Well, I showed you that the Babel documents demo. Okay, what are the use cases? So these are like some of the generic use cases. How you can use this knowledge graph along with the naive graph in order to make it like a more contextual and grounded stuff like that.
Ganges,
And
can you
then,
maximize the screen? Sorry, the previous slide we couldn't see.
Okay.
Yeah.
So these are the industrial use cases. So this is again like from the Neo4j. I just took the screenshot. You can go to like read more in terms of like any specific industry or use cases you are looking for. So basically, they have a pretty good material there. So you can take it and like read it there. And this is I just compared like these three versions of the databases. the Neo4j Nebula graph and Crusoe, and basically like this is a little bit on the licensing model and the pricing model. So I think that's all I have for now.
So Ganges,
Yeah.
will you be sharing
Yeah.
the presentation? No.
I'm sorry?
Will you be sharing this presentation?
Yes, I will be. After this meeting, so we'll share that through the either Discord or the Slack channel, so you should be able to see that.
Yeah, sure.
Okay. And then so it's really enough to. So there are like a lot of simple demo apps have been created by Nebula Graph. So maybe you can take a look at it. So this is like a GraphRAG versus RAG versus NL2 cipher, natural language decipher. So some of the questions you have raised, maybe like you get some answers by looking at these things. So when you look at it, so they have defined it like a very clearly, like saying that, okay, how the whole things are working from the Nebula graph perspective, from their implementation and etc. So this is like a pretty much like a same as like the code walkthrough what I did. So you can also take a look at it like by yourself with a bit of more verbose and information. And answer some of the questions. So if you look at it like, okay, vector versus a graph vector. So there's like this comparing, saying that, okay, just doing the vector embedding search, and then like a graph plus vector. So maybe like because of this tiny data set and the information is not as sparse. So basically like it is not very appreciative. Whereas the data set what Microsoft used, it is pretty huge and large. There you can see clear distinction or the advantage of like using GraphRAG, meaning like the GraphRAG, which is a plus naive RAG, when compared to just only the vector RAG. So here, like pretty much similar information, but it kind of like picked up like a few more additional information, which has been missed out only by the pure vector RAG. So in this case, like the vector, the embedding is like a small corpus, so probably picked up like a top 5, all this information they have got, but somewhere in the tail end, some information is like which is available for the graph to pull those things.
So Ganges, sorry, one clarification I'm looking for.
Yeah.
The Llama index was only used for the first use case?
No. It is used for like the entire stuff.
Okay.
So you can use see, because Llama index is even before, prior to the knowledge graph, right? They had this like vector-based embedding and vector-based searching on the downstream to the query and the summarization. Because at the time, like all they're doing is like abstracting the workflow, or that they made it like the LLM methods to call easy, right? So because like you setting up that LLM, whether you are OpenAI or the Llama 3 or whatever it is, then you are just kind of like composing that into an API call. That's what they're doing, right? So yeah, you can use Llama Index.
Oh, got it.
Llama Index or any other the tool chain. For example, like even any other framework. I mean, you can use the LangChain to do that. Right. So everybody has like the integration with the LangChain and the Llama Index, the Llama index is getting very popular, and then like they have a lot of integration, and then like the Llama hub, which is like the data store where you can have this storage mechanism, meaning like a storage in the sense you will have still go store your knowledge graph into the Neo4j or the Nebula or the Juco, but these guys have integrated from your code base to kind of access to that via APIs in a better way.
Got it.
Right. So if you look at it like, so this is one thing which the NL2 cipher to GraphRAG. So if you want to use the query, which is like completely like by the cipher, you can do this way. So then, but the way you look at it, okay, here, the depth is 2.
Sorry, we're not seeing your screen.
Oh, we're not seeing my screen. Okay, hold on a second. Sorry.
No worries.
You see my screen now?
Yes.
Yeah, this is the demo. So when I share my slide deck, you'll have that link to this one. So this is basically like the Nebula graph. They have created this demo. Whatever the code walkthrough I did, it's the same similar code. They've kind of like take it to a demo to sort of like run these queries. So let me, we'll see like, okay, instead of there's one, okay, Asim Chaudhary, because we have looked at see what happens. Ah,
Okay.
John. I tried with the Llama 3 there as well. The results were not as good as like what I got from the OpenAI, because they have restricted with some sort of like when I asked like for about like tell me about John Gunn, it started sort of giving me answers saying that okay, I cannot talk about like personal information about John Gunn, etc., etc. But however, in the context of Guardians of Galaxy, I can provide you that okay, he's the director and all this thing. So, anyways, this is
Nice.
all right. Okay, so I don't know, maybe it might break. It is all about their resources. Okay, John Gunn. Okay. Okay, it says, okay, there is no information. Okay. That may be true. Okay. All right, cool. So that's what I have for today. Thank you again for listening to this. And I will share that the slide deck with you guys later. Before we close, do you have any questions?
So I did have the question of the usability, and I mean, makes sense that this is a good pipeline to build the database with this pipeline. So there is essentially what you're saying is there is any corpus of data you can take and build this, and essentially we have this database ready to be mine information. So is that correct?
That's correct. That's correct. So I would say that okay, start with that from that perspective. Basically, like before even you jump into that fine tuning of the models for your data set, right? So take like the existing one, like this pipeline, and build with that one. If that doesn't satisfy your requirement, still you are missing that any information. which is not able to capture in that the knowledge graph, then certainly like you have to venture into fine tune the model. Basically, like for that as well, like I believe we can take the Rebel model and then like fine tune on top of it, because they have provided the data set, and we can take the look at take a look at the data set and then basically like create a data set similar to that one, and then using this the PEFT methods to do the fine tuning to extract this additional information which is like missing.
Understand. Do you, one last final question? Sorry, I know it's already 8:17. I should let you go. Do you see in future that LLMs can like agent take or whatever word we want to use, that there would be a pipeline in which corpus of data could be consumed directly inside of, and we just have to prompt it a particular way to say, hey, here is in which I want you to operate, and just to build me the appropriate database, whether you think this is SQL formed or this is knowledge graph, any kind. Just build it to me at the back end. I'm just going to consume this, and so the interface is an LLM interface. At the back, how it is stored, we don't care.
Right. Yeah. So certainly that is an opportunity. So because even I sort of like thought about that one, and even somewhere in the Llama index, one of the interview or with the Nebula graph, they were talking about that as well. So because that agentic approach is gaining ground, so you can sort of like do that agentic approach moving forward. That's certainly an opportunity. And this the scraper one, which I talked about, right? So they basically like did use that the latest Omni version of GPT-4o to make it as like a more multi-modal. So for example, like any corpus of data you can bring in, whether it could be a text or it could be an audio or it could be a video. So each one of them is like sort of like a firing into some agentic approach, I believe, internally, and then like it creates a graph from there. So yeah, that opportunity. I mean, there is a big opportunity. You can utilize that.
Nice.
So the way I'm thinking is, especially maybe like models like Llama 3, they may provide an easy way to, if you're hosting it locally on-prem, right? You can build this. Maybe there's an option in the future in which they can build this knowledge graph as part of that.
That is also there, but actually, like what, instead of using OpenAI, I tried with the Llama 3, okay, with the local model, and using the Hugging Face embedding model to sort of like do the embedding in the process. It worked, but I've not had time to go and like do a full thorough checking on the generation of the extraction. So that's where I did showcase that one. So, but yeah, very well you can use that one.
So one more question, Yangesh. So I think the interesting piece here is, in addition to building the knowledge graph, the other thing is like when the user inputs a query. From the query, how do you actually go to the knowledge graph and get the information, right? Let's see the information. Is there something we need to do some trick, or is it something,
No, that is pretty straightforward in a way. So basically, like let me share one more time.
It's like, do you see my? Yeah, it's like asking the right retrieval questions in the knowledge graph, right? So
correct. Yeah.
So that is what Llama Index is offering.
Okay, I see.
Llama Index, you can use the Llama Index to do that. Okay, so I'm just looking at maybe not doing this one.
I guess, do we really know the relationships? I mean, should we have read that Galaxy to figure out the relationships and kind of nudge, or does it figure it out itself?
You're talking
Uh,
about the graph building, right? That is a
Exactly. The SPO. What is
Yeah.
S, what is P, and what is O? Should we have read this corpus to create or should we have, what I'm trying to say is that, can it figure this out itself?
Okay, so that is where like they prompted that one. So internally, okay, so if you look at this one,
in that Einstein example, we know it beforehand. But
yeah,
if that corpus of information was stuck in it, can it kind of, given a question saying, hey, I think in that corpus there is somebody called Albert Einstein. So we know it's a human being. Yes, it's a human being. So that person has to have a father, has to have a mother, needs to do some vocation
So,
and all that.
Correct. Yeah.
Yeah,
So
custom
there is
retriever. I'm seeing something called custom retriever. So yeah.
I was not able to find my code base for that, particularly for the retrieval question you asked for, right, Krishna? So basically, like there is something called like a retrieval query engine.
Okay.
So with the retrieval query engine, you can do that. Okay. Okay. GraphRAG. Okay. Here it is.
Well, it's in my mind somewhere from the user query, some lang graph, lang for Neo4j or whatever the graph language SQL needs to be generated, right? So whoever doing that, that may be the library by Llama index. I don't know. Some library might be giving us the help.
No, that text to cipher is like generated by internally. So that's what I was explaining to the other person on the call, right? So you can just prompt it. Okay, the prompt, they take the prompt and basically it's similar to like a text to SQL, right?
Okay.
So if you can generate an SQL based on your query prompt, they are doing the same thing like with the user prompt in the natural language, and they're sort of like constructing the cipher query in the backend.
All right, thank you. So that is
the
where
reason is the reason is the schema is known because you have the schema. With that schema, they're kind of like gonna like figure out based on the keyword whatever it is in the prompt. Okay, that is what Nebula graph has implemented that way. But there could be extra additional configuration you can send as a parameter so that they can use to generate that query in a more effective way to traverse to the graph.
Got it. So yeah, I understand. So that's where depending upon the use case, we might need to customize, right? We have to play it around and see that.
Yes, exactly. Yeah. So that the prompt you have to kind of like do based on your use cases. For example, let's say in a security world, like I want to get all the user devices which have been activated from this period to this period, and it is like going and accessing certain site only during this period. Right. So you have
everything is free, or we have any work to do. That's what I'm trying to figure it out.
So the prompt you have to do it. So the prompt is like that you have to do basically like you can create some sort of like a prompt bundle based on your use cases, right? So basically like that part you have to do. Otherwise, maybe like I don't know, like based on somewhere the prompt has to come from the user, right?
No. Other than after the prompt is given, so retrieving from the graph model is nearly free to us, or is there any?
Yes.
Got it.
Yeah, that is free to us. Basically, like that part is already been like taken care by the underlying graph providers or through the LLM and then with the Llama index.
All right. Okay. Thanks.
All right.
Yeah.
Cool. I think we should let Asif go.
Yeah.
He's on a vacation actually.
Yeah, exactly. Yeah. So
in Seattle.
I have last question. Ganges, sorry.
Yeah. Yes, Albert.
So your graph is stored. So Neo4j is a graph database. So your graph is stored in the Neo4j if you want to, right? So Llama index provides that as a store, correct? Option as a store. Is that a
Correct.
correct?
Yeah. Correct.
Okay, got it.
It is. Yeah. That you are absolutely right.
Okay, perfect. Thank you.
Yeah, you need to have a database. So the database is like see, you think about it like, okay, it's similar to like the vector database, right? So you can have Pinecone, you can have Chroma, you can have whatever the database, which is like a supporting the vector database. Okay. But Llama Index is going to provide you the interface to that storage.
Got it. Absolutely. I know the vector database, it has all those stores. And I
Correct.
think for
See,
graph databases, it has Neo4j as one of its stores. Okay. Thank you.
correct. Yeah, Nebula, Neo4j, Kuzo, yeah, they have that one. That all the three are supported there.
Okay, absolutely. This was absolutely a beautiful talk. Thank you.
Thank you,
All right,
guys.
guys.
That's wonderful.
Okay.
Yeah, loved it.
Wonderful
Yeah.
talk. Thank you. Yes, yes.
Yeah.
So you're saying
Thank
this will
you.
be posted on the Slack or the Discord?
Yeah. So Asif said that okay, he will upload that into the Discord as soon as possible.
Got it. Okay. Thank you.
Okay. All right.
Enjoyed it. Thank
Cool.
you. Have a
Yeah.
good evening, everybody.
Thank you.
Bye.
Thank you. Bye-bye.
Enjoy your vacation, Asif.
Probably be out. Hey, Madhu.